Okay, the legs of the lifting platforms shown at the right form rhombuses, and you've seen these because in fact we do have one of these at the school. Okay. Now, can you visualize how this lift would work differently if the legs actually formed parallelograms that weren't rhombuses? What do you think would happen if these weren't rhombuses? It wouldn't pivot right, so what would it cause? It'd cause it to tip and maybe not be level, right? Okay, so that's one of the things. So you actually see parallelograms, rhombuses, you see them in a lot of places. And so what we're going to do is we're going to learn about some special parallelograms and their properties. So you have an exam, investigation 1. And if you notice in this investigation, it says you will discover the special parallelogram that you can draw using just the parallel edges of your straight edge. Okay. So on a piece of patty paper, use a double-sided straight edge. You all should have one. Okay. Draw 2 pairs of parallel lines that intersect each other. So go ahead and do that on one of your patty papers. Draw 2 pairs of parallel lines that intersect each other. This side. Did you get yours done?
We only have 4.
Oh. No, you should put it in. So, assuming that the 2 edges of your straight edge are parallel, you have drawn a parallelogram. Okay, because remember a parallelogram is a 4-sided figure in which opposite sides are parallel. Place the second piece of your patty paper over the first and copy one side. Don't copy the whole thing. One side of the parallelogram. One side, you're only drawing one line like this blue line right here. One line is all you're drawing in that parallelogram. Now when you do that, it says compare the length of the side on the second patty paper with the lengths of the 3 other sides. So what you're going to do, you've got your one side, right folks? You're going to now rotate that one side around and you're going to compare it to the other 3. So what do you notice? They're all the same, and so we've got a conjecture we need to write down. If 2 parallel lines are intersected by a second pair of parallel lines that are the same distance apart as the first pair, then the parallelogram formed is a rhombus. Nice job. Okay. So I'll let you get that down, and then don't put your patty paper anywhere. We're actually going to go ahead and use that again.
Mallory Brooker, 6,100, Mallory, 6,100.
So let's go ahead and look at this next one. It says, draw in both diagonals of the rhombus you created in investigation 1. So you're going to be drawing in these blue lines. Now, it gives you two options. It says use the corner of a patty paper. Since you have a second piece of patty paper, I would go ahead and use that. And it says to measure the angles formed by the intersection. So you see kind of how this purple sheet slid up there? Go ahead and tell me what you think about the diagonals. They're what? 90 degrees. So the diagonals are perpendicular. So we've got another conjecture. The diagonals of a rhombus are perpendicular and they bisect each other. The diagonals of a rhombus are perpendicular and they bisect each other. So real quick, do you notice, are the diagonals the same length? No, they're not. Okay, so that's one thing to understand. Just because they bisect each other does not mean that they're the same length. So let's look at step 3. It says the diagonals and the sides of the rhombus form two angles at each vertex. So really what that means is that I've got two angles here and here, two angles here and here, two angles here and here. Okay? Fold your patty paper. So basically you're folding it on one of the diagonals to compare each pair of angles. What do you notice? They're the same. So really, what do the diagonals do to the angles? They bisect the angles. And so the diagonals of a rhombus bisect the angles of the rhombus. Now that's a pretty important conjecture to get down. All right, let's go ahead and look at the next one. Okay, so now what I'm going to do is I'm going to give you some graph paper. Okay. I want you to draw a large rectangle using the lines of the graph paper as a guide. Okay. So go ahead. Draw a large rectangle. Yes. Okay. Okay, great. Okay, once you get that rectangle drawn in, okay, you can go ahead and draw on both diagonals. Okay, so once you draw that rectangle in, draw in both diagonals. So once you get those diagonals drawn in, you're going to need your compass. So now notice what it says. With your compass, compare the lengths of the two diagonals. So what you're going to do with your compass is you're going to open it to the length of the first diagonal, and then compare that to the second diagonal. Okay?
You might be surprised. We're going to say that.
Okay, so go ahead and measure them.
Mine's
No.
So what do you notice about the diagonals of the rectangle? They're congruent and they also bisect each other because a rectangle is a special parallelogram. Okay, so there's another conjecture we need to get down. The diagonals of a rectangle are congruent and bisect each other. Okay, so let's go ahead and look at this. This is an excerpt taken from your book. It says a square is an equiangular rhombus. Because equiangular means what?
All the angles are equal.
All the angles are the same. Good. And so we know a rhombus already has all the sides the same. So if we're saying it's equiangular, that means all the angles have to be the same, has to be a square. Or a square is an equilateral rectangle. Because what do you know about all the angles in a rectangle? 90 degrees. Equilateral means what? Sides are the same. Okay? So a square is a parallelogram as well as both a rectangle and a rhombus. That's really important to understand. A square is a parallelogram. It is a rectangle. Okay? And it is a rhombus. You need to make sure you understand that. A square is a parallelogram. It's a rectangle, and it's a rhombus. Okay, so let's go ahead and complete this conjecture. Since it is a parallelogram, a rectangle, and a rhombus, what can we conclude about the diagonals? They're congruent. What else? They bisect each other. What else?
They bisect the angles.
Okay, there's one other thing about the diagonals, and you need to think about a rhombus. They're 90 degrees, so they are perpendicular. So the diagonals of a square are congruent. They are perpendicular, and they bisect each other. Okay, once you get that down, we've got a few examples we're going to look at. And then we're calling it good for today.
side.
So, the diagonals of a square are congruent. They are perpendicular, and they bisect each other. You need to remember that. So let's go ahead and look at the following here, because this is going to be similar to what you have on your homework. PQRS is a rectangle. OS is 16. So if it's a rectangle, I know those are the same. I know these are the same, and I know it has right angles. What would OQ measure? Why? The diagonals bisect each other. Very good. The measure of QRS, so this measure right here, what does it have to be? 90 degrees because it is a rectangle. And PR, that is this length right here, 32, because the diagonals are congruent. Let's look at another example. ABCD is a rhombus. AD, so if it's a rhombus, I know all of these are the same. AD is 11. DO is 6. I need to find what OB is. What is OB?
6.
6, because it is the same as OD. What is BC going to be?
11.
11. And the measure of AOD, which is right here. 90 degrees, because it is a rhombus and they are perpendicular. The diagonals are. Any questions? Okay, this is the last example we're going to look at. It says determine whether ABCD is a trapezoid, rectangle, parallelogram, or none of these. So we're going to have to plot those points. So I've got 0, -3, -1, 2. Okay, so this is B, this is A. C is -3, 4. And D is -2, -1. Okay, so if I draw this in, I've got A to B, I've got B to C, I've got C to D, and I've got D to B. So first of all, let's see, is it a trapezoid? No. Okay, why not? There's two pairs of parallel sides. Okay, so is it a rectangle?
No.
And that should be obvious because it is 90. They don't have 90-degree angles. Next is a parallelogram. Is it a parallelogram?
Yes.
Okay, and this is the way to do that. You can count your boxes. If you look from B to C, A to D, if you look, that is just 2 boxes between each of them. Okay, you'll do the same thing with A to B and D to C. If you notice, to go from A to B, I go 1, 2, 3, 4, 5, up 5, over 1. D to C, I go 1, 2, 3, 4, 5, up 5, okay, over 1. So that's a way that you can kind of figure out if they're parallel or not. So it is a parallelogram. Is it a rhombus, just for kicks? Why is it not a rhombus? Not all the sides are the same. Okay, so your homework. Here you go, pages 294 through 295. I need you to complete for me 1 through 16. Okay? You can look in there, I don't think so. Okay, pages 294 through 295, 1 through 16.